Welcome to Network Nuts YouTube channel. I am Alok Shrivastava. In this video, let's talk about different ways in which ETCD can be deployed with Kubernetes. So you all know ETCD. ETCD is a key value store which is used by the Kubernetes to centrally store all the cluster information. Now, etcd can be deployed in two ways. One is the stacked etcd, which you see here. It's a stacked one. So stacked etcd means the etcd component runs on the same machine where the manager is. This is my manager. So manager is running API server, manager is running control plane, scheduler, and it is running etcd also. This is stacked etcd. So this approach is very good for us. A simple deployment, smaller clusters. All right, you don't want additional infrastructure for the etcd. So etcd is running on the same machine as on the control plane, and I don't need to manage it separately. Another feature is that because etcd runs on the same machine, I'm not expecting any latency between the communication between API server and the etcd, because they both are running on the same machine. So reduce latency between etcd and other components like control, manager, scheduler, and low overhead because you are not putting any extra infrastructure there. But there are some issues also. Issues are, if the manager goes down, if your manager goes down, you will be losing the etcd, right? You cannot scale etcd separately. If I just wanted to scale etcd separately, you cannot do it. And the performance is tied up with the manager. So if there is a resource crunch or something happening on the manager, that will be affecting the etcd. But this approach is a good one for like small clusters where you want simplicity, right? But then you trade off with the high availability, fault tolerance thing. These things are missing. So the approach, another approach is, why don't we have external etcd? External etcd means etcd machines are separate. Etcd will not run on the same machine as on the control plane, right? So control plane will not be running etcd. We have a separate cluster for etcd. Like here, API server is running on the manager, controller manager, scheduler is running, but etcd is not there. So etcd is running on a separate machine. So it provides you more fault tolerance. In this case, if the control plane goes down, my etcd is there, it is saved, ensuring my data consistency and availability. I can scale etcd separately. If I want one more machine of etcd, I can do it without adding any new control plane. I can have my dedicated backup strategies, restore strategies can be deployed, can be applied on the etcd cluster without touching the control plane. But then it comes with some concern, some extra work to do, obviously. See, it increases complexity in the setup. You need more infrastructure, right? 3 machines are needed here for creating a etcd cluster, separate node. So you need to have more nodes. It will increase the complexity, but yes, obviously it gives you benefits also, that as I have just mentioned, you can have a dedicated backup strategy for the etcd cluster. I can scale them separately. So external etcd normally is recommended for the production setups, for the production environments, big clusters. You will be seeing external etcd. Couple of things we need to consider while creating the cluster. That etcd relies on quorum. Quorum means majority, right? So for high availability, you should have odd number of machines, like 3 managers, 5 managers, right? Odd number of machines. And quorum or majority is considered when you have got 50% plus 1. Means if I have got 3 machines in the cluster, minimum 2 machines should always be ready. So I can afford a fault of 1 machine only. Similarly, if I have got a 5 machine cluster, then I can afford a cluster of I can afford a fault of or 2 machines. So normally we use something like this: n divided by 2 plus 1. N divided by 2 plus 1. Right? So 50% plus 1 machine should be available in order for the etcd to run properly. And then monitoring can also be configured separately. It needs comprehensive monitoring. Though it doesn't matter, monitoring will be needed even if you are running a stacked etcd or an external etcd. So what we are going to do, we are going to create a etcd cluster, external etcd cluster. First understand etcd, the operations, and then we will attach that cluster to a Kubernetes. So my API server will be referring to different IP addresses for accessing the etcd. Let's take it forward. Okay, so there are 2 ways in which you can configure a external etcd. One is the external etcd, this cluster. Here the etcd runs as a systemd service. It runs as a systemd service, which is fine, easy. Second is we can run etcd as a container also, as a pod also. So both approaches are good. Sometimes you might read in the documentation that running etcd as a pod is much more suited, because in case of the stacked environment, here also etcd is running as a pod. So we will try to give the exactly same environment to the Kubernetes, that even though it is external, but the etcd is running as the pod. But technically means it's solely up to you which method you want to use. So in this video, I'm going to show you how you can run etcd as a systemd service. Then in the next video, which I will be recording later on, we will cover how to create the etcd cluster, same etcd cluster, but here the etcd will be running as the pod. So let's take the first step first. How to run etcd cluster, configure a etcd cluster where the etcd is running as a systemd service, right? So I have 3 machines already installed for this. I'm going to share those machines. There it is. It's etcd1, etcd2 and etcd3. 3 machines are there, and the IP addresses are 192.10.0.0.10 2001 for etcd1, 2002 for etcd2. So that makes me easy to remember the host names and the IPs, and 3 is this, right? Now I have to install the binary. The basic steps are, you have to install the binary on all the machines and tell the service that we are running in a cluster and the other machines are at these IPs. This is what we have to do. So you can find the steps on our GitHub. Here it is. If you scroll down, I will recommend you to take etcd cluster understanding first. So this is my infrastructure. My machine is 201, 202 and 203. The host names are also same. Step number 1 is install etcd on all the machines. So just create a script here, this one, and I will run it, right? I copy this and I go to etcd1. Let's start from etcd1. So I say call it etcd-install.sh and paste the things here. Bash, that's all. It is good to go with root, because otherwise every time we will be needing sudo. So let's go with the root. Saves me a lot of keystrokes, else sudo will also work. Now let's do it again. So on etcd1 I create a file. I get the contents from the GitHub of networknuts, copy this, say I call it etcd-install.sh and paste it here. That's it, and run this sh etcd install. Repeat this on the other machines also. Let's first do this, right? So etcd got installed here. If I give etcd, I can see etcd and the etcd-ctl command line tool. Now scp this file to the other machines, right? To alloc at 10, or I'll simply copy it, because then I have to copy and paste and do the things. So I just copy it. I'll first create the script on the other machines. I call it etcd-install.sh and repeat it here, then I will execute it. Vim etcd-install.sh. So let's, because we are running as a systemd service, I need to have the binary installed. Otherwise, for the pod, we have to use the image. So I give etcd-install.sh here and done. Confirm it. Yeah. And here also sh etcd install. So etcd binary get installed on all the machines. Perfect. What next? I need to create a service. I need to start the etcd, but I have to tell the service file that we have a clusters, right? We are setting up a cluster, and these machines are a part of the cluster. Now, important thing to remember is that I am also creating a directory var lib etcd where the etcd is going to save the data. So default location, as you are coming from the Kubernetes background, you know etcd by default saves everything in var lib etcd. So I'm creating a directory here, and two directories I'm creating. One is for the etcd data and another is for the my service file, right? And then simply run this command. Specify the data directory location, advertise peer. You will have the machine IP on which machine you are running, but in the cluster you will have all the members of the cluster. So I had enclosed this in the curly braces, so I can simply copy paste this. On other machines, the only thing we are going to change is the local machine IP will change here in these lines, in these 4 lines. That's it. Rest of the things will remain the same. So I copy this up till here and do it on node 1, right? On node 1. So I go to node 1 and I paste it. That's all. It does the things automatically. Done. Now go to node 2 and copy the code for the node 2. Here the only difference is IP is changed, 202. Rest is same. So again I'm creating a directory, all the things, same thing. Copy it and paste it on node 2. Enclosing it in the brackets saves us a lot of time for creating the scripts. And now I go to code for the node 3, etcd3, copy it here and paste it on node 3. Job done, guys. If I check it here and okay, then I can check it. If I go to the etcd, I check the status etcd is active, it is running, and it is connected to the peers also. Peers means the other machines, right? Let's check it here. systemctl status etcd, yep, and on the node 3 also systemctl status etcd. Now we will be using some etcd commands to check the cluster. So the cluster is ready. How can I confirm? etcd command line tool has got its own command to check and verify the cluster. If you scroll down, here it is, check the status of the etcd cluster. From every machine you can give this member list, show me the members, endpoint status also. If I copy it and paste it, it's not necessary that if you are on etcd1 which has got the IP of 201, you should be executing the command from the same machine. It is some, you can execute it from any machine. You are just querying this IP address, right? See, etcd 1 2 3 coming, same I can repeat from here. So etcd2 can send the query to any other machine also, but let me use their own local IPs, paste it and change it to 202 because this is 202. It is also able to see, and 203. But 203 can talk to 201 also. See here, if I give 201, the query will be sent to that machine. So because the data is replicated, every machine in the cluster will be having the same view. Now I can see the endpoint status. One machine will be configured as a leader, and others are the followers. So that is also their endpoint status. So I can copy it and run it from any machine in the cluster. I put it on node 1. See here, though I am on node 1, which has got the IP of 201, I am hitting 202. It doesn't matter. See here. So this is saying that 202 is there, but then I have to repeat the commands for every machine, right? 201 and 203 like this. So this can be a tedious thing. So what I can do, just to make the things easier and the life easier, we create a variable here and write the IPs in the variable endpoints. Now supply this while querying it. So it will query all the machines. That saves me a lot of time. Now see the output. Here it is. All the 3 machines. You can clearly see 201 is the leader. Leader means the main machine. So writes on the etcd will always be through the leader. If any write request comes to the followers, which are non-leaders, they will proxy it to the leader, right? Remember that. So leader is the one which will be doing the writes, and if any write request comes to 202 and 203, which are not leaders, they will proxy it to the leader 201. Now let's write it then, right? If it is working, I should be able to write like something. I put a key value name Alok Srivastava. That's it. etcd endpoints put get and put. You were giving the command kubectl get reads etcd and puts the data. Here it is. It says okay. Now if I repeat the same thing and I say get name, I'm able to see it. I have put it on the manager, but I will be able to read this from any machine. So if I go here and if I 202, I say get name. See, name Alok Srivastava. So etcd2 is querying. So that data is replicated here also. And if I do it here on 203, I put get name, I get the data here. So data replicates. I have written it on the manager or the leader, it has been replicated to the other machines. Let's try it again. If I write something from here, if I write something from here, put say bike is Harley Davidson. It says okay. Now I have put from 202, but it has been going through the write is being done through the leader. So this should be visible to the etcd3 also. So if I go here and give the command get bike, I see it, bike Harley Davidson, and on the leader also get bike Harley Davidson, bike Harley Davidson, key value, it is coming up. So data you write from any machine, it will automatically be replicated to other machines. Now as I have told you initially that we have a fault tolerance of 1 machine. So if 1 machine goes down, I should still be able to get the data. So let me intentionally down node 2, right? This is the node 2, I'm making it power off. So still 1 machine is down, I should still be able to fetch the data because quorum is there, majority is there. 2 machines are still up out of 3. So this machine is down. If I go back and check the member list command, see it. I give the command member list. Endpoint status, wait, I say member list. It will show. See, I am querying to 202. 202 is not available. So let me query it to 201. See here. So it is showing. Why? etcd2 is coming up. But I have shut down the etcd2. You should check the endpoint status. If I check the endpoint status, I give the command here anywhere. kubectl endpoints is equal to, I supply my variable name $endpoints. And I say endpoint status, right? I hope you remember the command endpoint status. We had checked it here. Endpoint status here. Get name, get this, member list, write table, and we have got an endpoint status command. Just copy this. Here it is. So I can simply copy paste this. Why I am doing it again? So just paste it here. Show me the endpoint status. Now see here. In the endpoint status, it clearly shows you 1 and 3 at CD1 and at CD3. 2 is not responding. 2 is down. So one machine is down, but I should still be able to get the data. So if I give the command here, get bike, get name, it is working. Get bike, it is working, and it is available from node 3 also at CD3, right? So get bike working, get name working. So one machine is down, but still we have the data. I'll bring it back again, right? Now if I make 2 machines down, right? If I make 2 machines down, and I should be able to write also. The cluster is working, so I should be able to write also. Let me write something. Wait. Put, right? Put, let me put, say, training CK, anything. I'm putting it, right? Done. Now if I do get training, I'm getting CK. It should be visible from this machine also. Get training. Yep. So we are able to write. Cluster is working even if the one machine is down, right? If I make 2 machines down, then it will not be. But now we have written the data. One training data is being written when the node 2 was down. Let's bring back node 2. So that data should be automatically replicated and visible from node 2 also, right? I power on this. So basic understanding of etcd cluster is very helpful. We'll wait. It is working. Yeah. Let me log in on mobile XTEM. This one. Restart. Log in here. This machine is up. Right. Now if I query this machine, root, I go to root. Now if I query this machine, get training at CD2, I am querying his own IP. See, I'm getting it. So the machine went down and then we added something in the etcd. The moment the machine comes up, that data is replicated and distributed. That is the beauty of etcd. Now, but if I make 2 machines down, then I will lose the quorum, right? If you make 2 machines down, let's make 1 and 2 down, right? Let's make 1 and 2 down. So I go to etcd1. etcd1 is the leader. Currently, etcd1 is the leader. If you see the endpoint status, we have the command now, endpoint status, yeah. etcd1 is the leader, 201 leader true, and I'm making the leader down. Making it power off and making, say, etcd3 also power. Let's make it power off. Now I lost the access to the cluster because we lost the quorum. So if I hit onto etcd2, because that is the only machine which is visible, and if he tries to get that data, it's not responding because quorum is lost. See, member list, nothing will work, right? Member list is there, check endpoint status, it's all gone. Only one machine is there. Now if you notice here, right, so we lost access to the data. Whatever data is there, please remember, data is not lost, you just lost the access. Get bike, not coming, right? Now let me bring them again. let me bring the machines again. I make etcd1 power on, etcd3 power on. Now let's see what will happen now. I should get the data back and new leader will be chosen because the existing leader went down. etcd1 was the leader, it went down, so etcd will choose the new leader. They use a algorithm, they call it raft consensus algorithm. So the machines are up. Let me check. I press R, yes, it's back. I do a sudo -i, and similarly I do it on node 3 also, etcd3, and I do a sudo -i, and now if I check, if node 2 repeats the same command again, I'm getting it now. Wow, right? I get the data back and the cluster is up, everything is up, right? And endpoint status up, all the machines are up. So you should have at least this get endpoint status. Oh, sorry, we don't have the variable. I have to define the variable first. Yeah, now let's do it. Yeah, see here. Now check it out. etcd2 is selected as the leader, leader true, because the original leader went down. It flipped, was unstable. So etcd's raft consensus algorithm, it has chosen a new leader. Rest is same. So this is our etcd cluster running successfully. Now the next step, which we will take in the next video, is how to configure a Kubernetes cluster to use an external etcd. But before that, etcd cluster should be running, that we have. I hope you have understood it. Try it. Thank you very much.